In this video, I'll be showing you how to implement a swap on Curve. Curve is a decentralized exchange that specializes in swapping stablecoins. As you can see, if you input a rather large sum of a stablecoin, that the slippage to another stablecoin, in this case USDC, is quite low. So in this video, I'll show you how to implement this swap, not on the front end, but in a smart contract using Solidity. So we first need to build out the logic of the actual smart contract that will be interacting with the Curve smart contract. So we have this smart contract called Curve Swap, and it's going to be interacting with the Curve smart contract called Stable Swap. And there's a function inside of this smart contract Stable Swap called exchange. And the parameters for exchange are I, J, dx, and min dy. So I is the index of the array of the tricrypto pair. So we first need to create an array of addresses. So and in the Curve smart contract, it's the order is like DAI USDC and USDT. So I essentially is the index of the token in this array. So if I is 0, that would be DAI. If J is 1, that'd be USDC. DX is the minimum, that's the amount of token I to exchange. And min dy is the minimum amount of token J to receive. So we need to write a function that actually interacts with this with the stable swap contract. So we'll call it like initiate swap. So we're going to take it as we need to take, instead of like an address, we need to take a int 128, but that's kind of complicated. So we're first going to take it as a uint 256, and by default, a uint like this is a uint 256. So uint I, uint j, and uint amount. And this needs to be a public function, and it's not going to return anything. So, and we need, so dx essentially is amount, and min dy will create this variable here. So we'll have that as uint min dy, and we're just going to set it to 1 because it's just a small value. And essentially we're saying just swap everything, but you could set min dy to set like the minimum amount of slippage that you'd want for a trade. So now we need to, in this smart contract, we assume that that the ERC20 tokens are already in this smart contract. So that's, we need to first approve the stable swap contract to use the tokens in this smart contract. So we need to approve token I, which is the token that we want to exchange for token J. So approving stable swap and amounts. So we're approving this address and the amounts. And we need to also write a function that converts these uint 256 to int 128. So uint val public, and first we need to convert it to a uint 128, and then we can convert it to an int 128. So let's call it a val and we return b. And we also need to set this to All right, so this should work. Okay, so, and we have our int 128. So I, index of token I, so I'm going to call a function type convert. And J. And now we're actually going to call the function exchange in the smart contract stable swap, which is the Curve smart contract. So stable swap, we have its interface and its address. An exchange, I again is the index of the token, so that we want to exchange. So it's I, we have J, dx is amount again, and min dy, we already have that here. So this should work. And again, you could set this, you could set a return value here, but you don't have to for this video, this tutorial. All right, so now we're going to make another smart contract that, so actually we're going to change this, to internal, so that only functions inside of the smart contract can call this function. Otherwise, anyone could come along and swap any token. You can call this function, so we don't want that. So we're going to create a smart contract called swap that actually, so a user can come along and, like for example, Alice. Alice can come along, deposit some token DAI, and then we take this DAI, our swap contract, and swaps it on Curve. Curve sends us back USDT, and then Alice can withdraw USDT from our smart contract. So we'll be building out swap contract. So what we just built, Curve, is essentially the functionality that allows us to interact with the Curve smart contract. So we need to create just the functionality, essentially what I already explained, with like a user can come along, they can deposit some ERC20 token, a stable coin, and then we'll swap it on Curve, and then that user can withdraw the swapped token from our smart contract. So we need to import what we just wrote, so that we have the functionality and all the functions in this file. So contract swap is, I think it's Curve swap. Yeah, so Curve swap. So we're inheriting the functions from Curve swap. Well, swap is inheriting from Curve swap. So also it's important to use safe ERC20 for ERC20 functions. So otherwise, sometimes like I've just had problems in the past where with working with ERC20 tokens, if you don't use safe ERC20, it just doesn't work for some reason. Especially like, yeah, it just depends on the ERC20 token. Some ERC20 tokens it will work, and for others it won't. So we're also going to create like an address of the person the account that deployed this smart contract. And we also need to create a mapping that keeps up with balances of users. So we're going to create a mapping that maps address user to address token to uint balance. So address to, we're going to create another mapping, address to uint. And we're going to call this, it's going to be public so anyone can view it, and we're going to call it balances. And also, it's important to note that even if it's private, you can still view all the data that's in here. It's just, it would be slightly more difficult to do. So we need to create another constructor. So and we're going to be setting owner to message.sender. All right, so now we need to create a function that the users can deposit the ERC20 token. So it's going to take the address token and uint amount. It's going to be a public function, so anyone can view it, anyone can call it, and so we call the interface of the ERC20 token, address of it. We're going to do transfer from. And it's also important to note that the user has to, Alice in this case, would actually have to go to the DAI smart contract first and approve the address of swap contract to be able to deposit. So we will write that in our test. So I'll show you that in a minute. But so yeah. Otherwise, this transfer from would fail. It would revert. So message.sender to this address and amount. Okay, so now we need to update the value in our mapping. So balances, so user to token address, and we're going to set it to amount. And we could set this to return something, but in this case, we're not going to set it to return anything. So now we need to create a function that the user can withdraw tokens. So it's important to create a require. So some random person couldn't come along and withdraw any amounts of ERC20 tokens. So we're going to say that require balances message.sender token is greater than or equal to amount. And if this is not true, it's going to revert with a message, not enough balance. Okay, so now when we withdraw, we need to first update our mapping. Amounts, so we're subtracting amounts, and then we will transfer the token to the user. Okay, so again, this function doesn't have a return value, so just test that this works. Okay, so in Curve we have an error. Okay. All right, awesome. So now we need to actually make a function that implements the logic that actually creates the swap. So we'll do like initiate. Wait, let's see. Let's make sure that, yeah, let's call it initiate. We can just do it like swap. And we'll do address token in, address token out, and uint amount. It's going to be public, anyone can call it, and it's not going to return anything. It's probably best to have like a return value, but for this video, we're not going to have that. So we need to create a require so that not just some random person can call this function. Token in and greater than or equal to amounts, and if it fails or if it reverts, we're going to say not enough balance. And so now remember in this this function here, we're taking an input as like a parameter, a uint. So we need to convert our address into the index of the address in the array. So we're going to create two variables, so like index in, and we're just going to do this with a for loop. So I is less than the array tokens length, and that array is here. So if tokens I is equal to token in, index in is equal to I, if so I'm just doing the same thing for index out. Okay, so that should work. So now we need to create another parentheses here, and we're actually going to call the function stable, or yeah, initiate swap. So initiate swap, and we need to, our parameters are index and index of token in, index token out, and amount. So we have index in, index out, and amount. And so now we need to update the mapping that is in our smart contract. So balances message.sender, and we're actually going to be subtracting the amount that we just sent to Curve. So token in, amount, and now we need to we're going to update this again, but with the new token. All right, so token out is equal to, so yeah, we should actually create that. So we need the balance of token out. So token out balance is equal to token out dot balance of this address. Okay, so now we need to update this. So token out balance, and that should be it for this function. Wait, why is this here? All right, let's make sure that this compiles, and all right, tokens. All right. Okay, so this should work. So what this function does, it takes an address of token in, so die, address token out, and amount of token in, which would be die, and it swaps it on Curve. So Yeah, so let's, so I already wrote a test for this. I'll go through this quickly. So what we need to do, so we have address of DAI, address of USDT, and we have address of DAI whale. So this is just the user on mainnet, an address that has a lot of DAI in it, and will be essentially this DAI whale is Alice in this example. So Alice will be depositing DAI to our swap smart contract. We will swap it on Curve, and then Alice can withdraw USDT. So we have DAI, which is the smart contract, in this case USDT, and our smart contract, swap contract. And this is how you can impersonate like an account on mainnet. And we get DAI and USDT. So we first deploy the smart contract, and yeah, so I'm doing this twice. I don't know why, that's a mistake, but okay, it should work anyways. So we deposit DAI into the smart contract. So DAI connect as DAI whale, and we're approving the smart contract swap contract, and balance, which is the entire balance of DAI that the DAI whale has, this Alice person. And then we connect to our smart contract that we just wrote, swap contract, and we are calling the function deposit. So first deposit, and then we need to call, so not initiate swap, but we just have it as swap. And so we swap, and then this test is actually withdrawing USDT. All right, so let's see if, so this is a new NPX hard hat node, and I have this set up so that this is a fork of mainnet. So NPX hard hat network local host test curve swap test. So let's see if this works. And again, hard hat is notoriously slow for tests, and if you restart the test, sometimes it runs faster. Like, I don't know why that is. So this first test went through. We deployed the contract. We deposited DAI. This is an amount. So take off 18 decimal places. So around, I don't know what that is, but somewhere around 1 million. So yeah, that is so $9 million or 9 million DAI. So 9 million DAI. So 9.4 million DAI, and then we swapped, and we can see that, so we swapped the DAI, and we have, we added 9.4 million USDT to the user, Alice. So I hope this video kind of cleared things up. Maybe it was pretty simple, but all the code will be on GitHub. And if you enjoyed this video, if it was useful, please leave a like. Thanks, and see you next time.